Let's talk about writing complex numbers in trigonometric form. So you remember that a complex number is a real part plus an imaginary part. So let's just imagine that I had something that was x plus yi. So in the complex plane, right, that would say that I was a distance of x to the right, a distance of y up, and this point would be x plus y. So we could also represent yi there, and then that point as x. Okay? Trigonometric form says it might sometimes be easier to represent this point not with the distance horizontally and the distance vertically, but with the distance of this hypotenuse, the hypotenuse of this right triangle, and this angle. Well, the angle we call theta, and the hypotenuse often we call r for the radius, if you think about this as being a circle. Those two numbers, you could actually represent these quantities just fine. Well, how do you write x in terms of r and theta? Well, you remember that the way to relate the adjacent side and the hypotenuse of a triangle is cosine. So you might remember that cosine theta equals x over r. And so with a little bit of work you can say, well, x is actually equal to r cosine theta, right? And then y is related to r and theta by sine. So sine theta is opposite over hypotenuse, so that's y over r, or we could just write y equals r sine theta. These two equations pop up a lot in this stuff. Okay, so how could I write x plus yi without ever referring to x and y? If I knew the radius and the angle I've rotated counterclockwise from the positive x-axis. Well, the answer is, instead of x, I write r cosine theta, and instead of yi, well, the I still is sitting there somehow, but then I write r sine theta. Okay, so trigonometric form is, we factor out the r, but it's essentially this: r cosine theta plus I sine theta. If you know how far you've gone and the angle you've rotated, you can write down this number in that form. Now, occasionally, so that's trigonometric form. Occasionally, what we do is we write this in shorthand, since every single time you write it in trigonometric form, you're going to have cosine theta plus I sine theta. Sometimes we write it in CIS form. That stands for cosine I sine theta. This is understood to be exactly the same as this. This is just a shorthand. So when you see r CIS theta, what that means is it means r times cosine of theta plus I sine theta. And that represents a point in the complex plane. So I think it makes way more sense to do this sort of with an example. So let's do an example over here, and you can sort of see the two at work. Okay, let's look at, say, 4 plus 3i. So that means I go 1, 2, 3, 4 over. I go 1, 2, 3 up. This is the point, 4 plus 3i. And you can just write it 4 plus 3i. I started with one that's easy to write in terms of x and y. In the future, we'll think about things that are easier to write in terms of theta and r. But just for comparison's sake, this one's fairly easy. How do I find r? Well, I picked one that was sort of easy on myself. A squared is 4 squared, b squared is 3 squared, right? And the hypotenuse is r squared, so this is 25 equals r squared, or r equals 5. That's the old 3, 4, 5 right triangle. Then how do I get theta here? Well, if this side is 3 and that side's 4, how can an angle be related to the opposite and the adjacent sides? Well, tangent of theta equals 3 over 4. Inverse tangent works just fine in this quadrant. So theta equals tan inverse of 3/4. And you can say, well, what is that? That's about 37 degrees. Okay, so this point can be written as 5 cosine 37 degrees plus I sine 37 degrees. Or it can be written as 5 CIS 37 degrees. Now, sometimes it's easier to think about a number that way if you're not going straight right and straight up, if pragmatically what you're looking at is the distance from the origin to this point. But it's also drastically easier to multiply and divide those numbers. But I'll show you that in another video.